who's ready to see some like just awesome digital twin stuff? Come on, guys, let's like really get pumped here.
Yeah.
Woo!
All right.
I think we can do better. You're going to be applauding more at the end, I promise.
right.
So we're going to take you through basically a couple things here today, depending on time. So first of all, as Brian Harris talked about on the main stage, Sterilcentral is kind of our lead customer for digital twins that we're showcasing this year. And we're going to tell you a little bit about their experience and their journey with the SaaS product and the problems they faced and how they ended up using our digital twin technologies to solve those problems. Then we're going to spend quite a lot of time talking about the broader industry applications. So Sterilcentral is a medical application of our technology, but we'll be showing you lots of different examples of lots of different industries so you can see the flexibility behind SaaS's digital twin tech. And then if, and only if, there is time at the end, we will try to do some Q&A because we're here live, we love to engage with the audience, but like, you know, we got a lot to cover, so we'll try to go fast, but think of your questions now. We might get one or two in. All right, so there's one takeaway for anything from this presentation. It's that digital twins are really, really good at solving a vast array of highly differentiated problems. You can see 6 examples of these problems here. I'm not going to read them. But the point is, I think when we typically think of technological solutions, we sort of think of one hammer, one nail. And digital twins are more like a laboratory. Once you build the laboratory, there are all sorts of different experiments you can run. And that tech is really one of the reasons why SaaS is so excited by this, because the power of that twin flexibility hooked up to VIA is enormously valuable. And I should also say, and I think this is probably honestly the thing I think is just so cool in all of this, is that all of the twins SaaS makes use the Unreal Engine. And we do that in partnership with Epic Games. For those of you guys who don't know, Epic Games makes like Fortnite and Rocket League. They basically, most AAA video games today are made in the Unreal Engine. And we have this very close partnership with Epic Games specifically because we wanted to work with the highest fidelity rendering engine on the market, and that really is Unreal. So some of the visuals and things that you're going to see here are really cutting edge, and that's thanks to this rich, productive partnership we have with the Epic Games folks. All right, let's talk about the Sterilcentral customer experience. So Sterilcentral came to SaaS with a problem. They had a medical sterilization facility in Copenhagen, and it was not performing as well as it needed to. They felt that there were many opportunities to increase the efficiency of that sterilization facility. At the same time, that facility was up and running. They needed to deliver instruments to surgeries that were sterilized to save lives. So they didn't have a lot of options about maybe shutting the facility down and experimenting with different layouts. They needed a way to assess the optimization of what was going on in the facility on the fly. And so SaaS came in, and what we did is, the starting point, we built a digital twin, a one-to-one replica of their Copenhagen facility. So on the left, you see a real-world footage. On the right, you see the twin footage. This is actually, Paul and I could even swap this to a better image. We have even more updated versions of this. But the idea is, we were able to get a very, very, very close visual replica of the facility. And that's going to come a little bit more important later. So not only was it accurate, down to the millimeter for the optimization problems we were going to tackle for them, but that visual fidelity was really key. Yeah. And so our first step was we wanted to look at, okay, how do we optimize this thing? What do we do? What's wrong with the operation? So what do we do there, Paul? How do we handle this?
Yeah, so we realistically modeled all the important pieces of machinery throughout this facility, right? There's all kinds of telemetry that would generally come out of AGVs, or automated guided vehicles, of which here they had 2 types. They had these large lift AGVs. They're more similar to the forklifts you might remember from our GP project last year. And they also had these little mini cuter AGVs that had little sort of roller conveyors on the top, and those just transport around these surgical trays of instruments. So they have a clean and an unclean side. Basically, things come in from surgery, right? They need to be pre-washed before they can even go into a washing machine. I won't get too gory here, but you might imagine why. And then, so they have different safety standards on both sides. If you think about how this process would flow, a person is washing one tray at a time, but when something comes out of the washing machine, it would come out with like 8 racks, all on one instrument wash rack. So it's very lumpy on the clean side when they come out of the washing machine. This is actually causing one of the biggest problems we found through this simulation analysis, is that the staffing shouldn't really be static or equal on both sides, because it's steady state on this unclean side of, okay, you just call up one tray, one tray, one tray. On the other side, you're getting a whole bunch exiting the washing machine all at once. So, yeah, so we were able to answer all kinds of data questions. We were able to show that, as Brian mentioned, the buffer lift was not really the bottleneck. It seemed like it might be, because the dwell time, they called it, basically the amount of time that inventory was staying in the buffer lift, was far too long. But this is because it wasn't getting called out by people at the tables, because a washing machine wasn't open, because on the clean side it wasn't being packed fast enough. So really, you know, it's this chain reaction, and the problem was in fact on the complete other side of the facility. So.
Yeah, and as Paul alluded to, we're able to sort all that out because we can run so many different scenarios basically instantly in the digital twin. It's as easy as like clicking the mouse a few times to move something around or double staffing or increase the throughput of a machine. But remember I said that high visual fidelity is important, and you can see here, like, this looks really realistic, right? And that realism was very important for optimization. Not so much, but for the next challenge we tackled with Sterilcentral, which actually had to do with a completely different issue they were having in this facility. This is a sterilized facility, and they were dealing with a challenge of individuals walking into the facility not correctly wearing their protective equipment or their PPE, right? And that is a huge challenge because it's a sterilized facility. And not only that, but it's actually very difficult for Sterilcentral to get footage to train a computer vision model to detect violations on something like this. It's difficult for them to get footage because that would require them to have people wandering around their sterile environment without wearing proper PPE, right? Like, you can't do that. And so because we had this twin built to incredibly high visual fidelity, we were able to use the twin to generate mountains of synthetic data to train a computer vision model to detect these violations.
To jump in quickly too, another challenge there was that you couldn't really record people in their facility because of regulations around, you know, workers' rights and rights to be filmed, to be recorded in the workplace. So it is impossible to get this footage. Even if you could get it and hand label it in the old-fashioned way, it was not possible in this facility. So
we touched on, we love Sterilcentral as a customer use case because there was the optimization value of our twin, but there was also this, we call this synthetic vision, training computer vision models on synthetic data that is entirely twin generated. Sterilcentral also had this synthetic vision challenge that we were able to solve. And going forward, we're going to use that synthetic vision to address a number of potential opportunities at Sterilcentral. We're interested in detecting the case packs and seeing if they're being appropriately packed. We're interested in medical process compliance, so if there's any HLS folks and things here, that is definitely something twins can help with. We're interested in actually detecting the sterilization on the tools themselves. And potentially, Sterilcentral might need to open other facilities. It's in their plans. We're actually looking at doing optimization of greenfield sites. So again, all of this, these vastly divergent use cases, all being solved and addressed by the same underlying digital twin. So we told you the Sterilcentral story. Now I'm going to turn it over and give my clicker to Paul. He's going to lead this next part as we talk through the broader industry.
Additional, more interesting, broader applications here, maybe. So just to go back to what we did last year one more time. Operational efficiency, right? So we talked at Georgia Pacific about optimizing routes and missions. Here in Sterilcentral, it's more of an overall process flow for trays of surgical instruments. But there's similar problems, I'd say, that you encounter in these sort of mixed automated and human operator environments, because the slowdowns can be caused by either humans or equipment breakdowns or a mix of the two. And we see all kinds of new, I think, applications here in the future. So we started with a paper plant, right? That's what it was for Georgia Pacific. It doesn't sound that high tech, but they do use a lot of automated robots there. This is a very high-tech looking facility in Denmark, but it really could apply to all sorts of modern environments where there are operated processes or machinery. So a little bit, just a tiny bit under the hood, even though I'm not great with Unreal Engine. John Campbell, superstar shout out, he's in the back there texting, but yeah. our Unreal Engine expert. But yeah, essentially, we have the ability to take a bunch of JSON that basically, it's a giant JSON array, right? Text document. Each object in that array is just defining a scenario. So you can define a different number of avatars or actors, what they're going to wear in the scene, if they're missing some protective equipment, for example. Or you could queue up unsafe behaviors if you're trying to do event detection of this data, right? Like leaning on a conveyor belt, something like this, right? That's not safe. So we have these sort of scenario definitions. These get ingested, and then one at a time, you create a little mini scene in a video game. You can think about it like this. It's essentially spitting out either labeled images or entire video. And we have all the bounding boxes for, say, like a hairnet or your mask or a gown. We know the positions of all these objects because it's in the game, right? So we know where the projection is in 2D space. We have perfect boxes drawn for everything, unlike hand labeling of object or event detection data sets where it takes months or years and there's going to be noise or missed labels or problems in it, right? So here it all just comes together through the power of Unreal. So you might also ask yourself, this was my major question I had some skepticism about in the beginning. If you train purely on synthetic data, can you actually get your model to transfer to the real world and have, pretty solid performance in the real world where we actually care about it? We have mostly determined that yes, we really can, and it has been quite successful. So just to go back to some of the challenges you generally have in traditional approaches, some events either should be rare or are very rare, like accidents, like explosions, people getting hurt. Or we said like impossible scenarios is another example, right? We couldn't even collect footage of people not wearing their hairnet walking in because they don't want you to do that, right? For obvious reasons. In this kind of environment, you can't ever really break the rules to make any training data. So, but in a twin, you can make as many versions of that forklift crash or person not wearing their helmet or whatever it is as you'd like. You can change the lighting conditions, camera angles, add some noise, add some fisheye lens distortion, whatever you want to make it look just like the real world footage. And this allows our models to then transfer much better across domains to the real world. The next is the hand annotation. I don't know if anyone here's done any computer vision in the past, or any kind of data science. Labeling your data is terrible. It takes forever. And for computer vision in particular, it's terrible because say it's 30 frames a second video and you want to label, let's be conservative, 100 hours. You have millions of frames of data, right? So this is going to take forever. You don't have to label any of it yourself. Unreal Engine labels it for you. Scenario analysis can be costly, so I think prime examples here would be like accidents, right? NASA made the first things you might call a digital twin for the space program. It's too expensive to mess up, right? So, or to act it out, right? Acting out an accident or a crash in your facility. It could be dangerous, it's definitely going to be expensive and time consuming, and you'll still only get a couple examples. To train a robust model, you need thousands of examples, right? Of these classes that are generally very rare and imbalanced, in your data set. And then finally, this is a really important one, PII. You got to remove everyone's faces from the training data. They get encoded into model weights, and then that's there forever. So you have to remove any identifiable information. Faces are a good example, but if someone's ID badge is in some of this footage, right, or who knows, documents with addresses, whatever, if there's even little things in the background, it's a problem. You have to remove it before you can train your model. Also, traditionally, if you're getting data from one customer, making a computer vision model for them, only that customer can really be sold that model. It's not generic. You couldn't take that model and sell it to someone else because it was trained on that customer's data. But because we were able to make these pretty generic spaces and where we can use techniques like procedural content generation to really vary the scenes, vary the arrangement of items on shelves, for example, in a warehouse or a factory, arrange the layout of conveyors, whatever. We can make pretty generic models that will basically work anywhere, not just in places that look like the twin footage that we produce. So, pretty nice, right? You can actually reuse and resell this stuff. Our first successful use case is worker safety, which I think we've talked about a bit. You saw the Sterilcentral version of it, which is really more like hygiene equipment for surgical caps and gowns. But we also have industrial safety models. Those are GA actually, and this is all in collaboration with Udo Sklavo's great group of advanced AI and modeling folks. They actually train all the models. We just make the pretty training data, so it's a great collaboration there. We have a whole bunch of other fun applications we're going to show you a video of in a second, but quickly, yeah. I'm going to get to it there. So we got defect detection, training and maintenance. I have to do something a little unorthodox. This video is too big to properly embed in a PowerPoint, so here we go. So we got oil and gas sector here. We can identify leaks and fires in real time. You can see we've got some telemetry too, maybe coming out for say pressure or energy fluctuations. This all lets you do what if scenarios as well, right? So you want to say like, see what happens when there's a storm surge, how does it impact your operations? So we can do all this in our twin. We can also do entire supply chain here, from upstream, midstream to downstream for oil and gas. In lab safety conditions, we can track vials and samples, make sure things have proper chain of custody, aren't left out too long, aren't missing their labels, so you have to have your blood work redone at the hospital, which has happened to many people in my family, and apparently to Brian's dad recently. It happens a lot. And then in manufacturing, here, William, do you want to?
Oh yeah, I mean, this is the use case I love the most, is this product defect detection, right? And this is particularly valuable for product lines that have a very high refresh rate. So like I worked in toy, for example, at Hasbro a long time ago, and we were always doing seasonal variations of the product. It made it almost impossible for CV to detect there.
Do you want to keep talking? Yeah, because I think it's a really interesting use case. I know we have a minute, but I think it's pretty.
Yeah, this is just literally as easy as you can upload the new packaging files. It automatically skins the product, and you're instantly retrained on your seasonal SKU, your stickered SKU, your refreshed item, whatever it is. So huge CPG applications here for this.
Yeah, and again, if you're hand labeling this, every time you add this new red bonus sticker or whatever for a temporary amount of time, it might get a bunch of false positives on your computer vision model saying, oh, that package is damaged. It's not supposed to have a thing on it, right? But yeah, and then quickly we got our final application here, which is going to be energy and utilities. You can imagine inspecting damaged power lines. So you might have seen this clip, I think, in Brian's talk earlier too. But the idea is we can look for things that are either already damaged and sparking, but ideally we try to intervene before there's failure. So we try to see if there's a corroded fuse cutoff, for example, or a transformer that looks like it has some damage. So we inspect all this drone camera footage, right? You can process a ton of it with models and then score it and figure out the results. So I believe that brings us to Q&A.
Yeah, I think we have 2 minutes left, so maybe we have time for one or two. Wow, your hand went up quickly. Did you want to ask something, Sharon? Okay. Do we need a microphone or you can ask and I'll just repeat the question then.
What's being used as a training data and testing data, if that makes sense. So typically
Yeah. Good question.
actually record, so how do I
Yes.
know if the model is actually working?
Yes, we don't have a lot of labeled or any labeled test data, right? So we have validation data. We try to get the model to perform as well as we think we can. But for one of the things we can do is create new scenarios to make new data that is completely different from even the holdout data, right? It's still synthetic, but see how it performs on this, right? Sort of a secondary validation set. And then we just have to really just run it on footage and assess it, in the wild, basically. That has been our, yeah. But it's a very good question, yeah.
We have another question here. Sharon?
Yes.
Srinivas?
Here, and we have someone in the back as well, yeah. It's so loud in here, yeah. Do we have are we, yeah.
The question there was, do we see synthetic data being used for robotics applications? And the answer for that is like, yes, 1,000 times yes. That's probably one of the best use cases for it. And that governs everything from actual robot training for performance in world, but also some of the computer vision stuff there matters as well in terms of discipline and compliance for the robot procedures.
Yeah.
And one more question. Yes. Yeah. Just ask me and I'll repeat it, yeah. Okay, so the question there was, do we have plans to offer a digital twinning capability for a nuclear power plant? And I think the short answer for that is let's talk offline.
Yes.
The longer answer is we have a number of tools that are applicable to energy and utilities technologies. And yeah, I think plant optimization and process optimization can apply across really any level of complexity of procedure. It's just the amount of time it takes to build the twin. And with that, I think that's going to wrap up our spotlight session. So thank you all so much.